Hello guys, welcome back. In this video, let us learn data pre-processing. So why I need to learn this, sir? If you are expecting to become a data engineer, then this becomes an important task to you. And not only there, nowadays everywhere we are using this data processing. If you take an example of creating a generative AI application related models or machine learning models. So before creating them, we need to train those models. In order to train those models, we require to provide the data. That providing data must be pre-processed. That is, before training your data, you need to make your data or pre-process your data that is suitable for training. So in this data pre-processing stage, we will need to understood how to load any data and how to drop. If there is any unnecessary columns are there, then how to drop those columns or remove unnecessary columns of data. Let's say in sometimes in our data, let's take a structured data set like CSV file I'm taking. Now in that data set, sometimes I might have unavailable data or missing values are there. So during that time, we need to fill that missing data as well, right? Yes. So that filling the missing data within that data also we'll see. And so before sending our data to our model, we need to convert one category to another category. Sometimes we might have a requirement to convert the data from one category to another category so that it is easy for the model to understand the data. So that also we'll understood. And so the important part, if you are training any model or if you are training any neural network, the model may be any ML model or generative AI model, you need to split the data set into two parts, that is a training data as well as a testing data. So if you do that, then you can able to identify the accuracy of the model. After training your model, how much accurately that this model can able to identify or predict the output that you can able to identify by using that test data set. So we also understood splitting the data set into training as well as testing data set. Then after splitting the data set, it is very important to normalize that data set because some values might be very large and some values might be very small. So during training or during processing, the overburden maybe falls on our model. So in order to reduce that, we need to standardize that data set. We need to normalize that data. So that also we will see how to do that. Now, first let us understood how to load a CSV file. Let's say I'm taking a reference like I'm taking a Titanic data set and I want to use this Titanic data set to identify, to train my model with this data, and I want to identify how many persons are able to survive and how many persons are unable to survive. That I want to predict. This is the URL that I have provided. In this, you can observe survived or not. So that value also provided here. So I will take I'm taking this data set as a reference and I want to train my model to predict how many passengers present in the Titanic ship can able to survive. That I want to identify. So first I want to split my data into two parts, like I will take that surviving data as survival is true or false, that data as output, and rest of the data I will take as input. So by providing all the input, and I'll identify whether he can able to survive or not. Let's see what is the data processing involved here, or let's see the general data processing that we can able to perform by using any data set. Now first I want to load this data set. This is a CSV file. I want to load this. So in order to load this, we need to import pandas library. So by using this, we can able to import. I'm importing pandas as PD, and by using that PD dot read CSV method, I'm going to read the CSV file from the given URL and storing that value in this data variable. And let's print that data to check whether I can able to read that data or not. You can observe I'm getting the data. So totally 891 rows and 12 columns are there. Now let us see what are the columns I have. You can see, so whatever the columns that are seen, those all columns are there. Now, in order to process this whole data set, I don't want certain things like in order to identify whether a person is survived or not, I don't want that particular passenger ID or passenger name or passenger related ticket number or passenger cabin. I don't want these four columns in this data set in order to test my data. In order to train my model to identify whether that particular person is survived or not, I don't want these four columns like passenger ID and name as well as a ticket as well as cabin. So I want to remove those columns from this data set. How can I able to remove those columns from this data set? To remove those columns from this data set, so you just need to write the command that is data dot drop. So you can see the method is visible and which columns you are expecting to drop. So that you need to provide. So columns I'm writing. Since this is not a single column, I'm providing a list of columns. And first, what column I want to remove? Passenger ID. Passenger ID. In Pandas, you can remove the data set columns like this. So passenger ID I'm removing and name I don't want. So I'm providing the name and I don't want the ticket. So I'm removing that column as well. I don't want this cabin column. So that's why I'm removing this as well. And storing that resulted data after removing these columns into this data variable itself. And let's see that data, what data currently we have. So currently we have just 8 columns. Previously, how many columns we have? We have 12 columns. Now, whatever the 4 columns that we provided, those 4 were removed and we have only 8 columns of data. Now, let us see the missing data. If you observe this age column, this contains NaN, not a number. So not a number value, that is nothing but none value is there. So like that, in your data set, you might have some data missing. So that data also you need to fill it. Since this is an age, I want to consider the mean of all ages and I want to fill all the empty positions. So in order to fill this, I'm writing the command that is, so at where I'm expecting to fill a data of age column, I want to fill. So dot fill NA columns. So, and we need to provide the data. What value we are expecting to fill? We are expecting to fill the mean value of all the ages. So I'm taking all the ages mean, calculating it and filling in that place of not NA value. And I'm providing here true. So not only this, in this embarked also some columns are not filled. So I'm expecting to fill that embarked column as well. So fill not available values with data of embarked dot. So whatever the value that comes more times, S value I'm coming more times, or C value is getting more number of times. That value I want to print. So in order to get the more number of times value, that is nothing but mode. So whatever the observation that comes more number of times in the data set, that I'm taking and I'm filling in the place of not available value. And at last, let's print the data to observe whether that NaN data is filled or not. Now you can observe the ages. Then you can able to identify that there is no NaN age. That is there is no missing value. So in this way, you can able to fill the missing values as well. Now let us do the thing that is convert the data set. You can see here we have the sex, that is either male or female, and embarked values like SSC and Q values also there. Now I want to convert these categories. I want to generate some dummy data in these 2 values and I want to provide that. Since here multiple categories of values are there, machine cannot able to understood multiple categories of values. We can able to understood what is male, what is female, like that. But machine can understood only zeros or ones. That is either true or false. So I want to convert these into different categories. So let's do that categorical conversion of data as well. So in order to get that dummy data from this data, so you need to use this PD, that is pandas.get dummies of. So for what data you are expecting the dummies. So for the data I'm providing, and for what columns, data is the data, for this whole data I'm providing, and for what columns you are expecting the dummies. You can see here it is even providing the hint. Currently by default it won't take any columns, none it is taking. Since I want the columns to be these 2, that is 6, and the second column is this embarked. So I'm providing those 2, and at last I'm storing the data in this data variable itself. And let's print that data. Now how our data will be. Why we are doing this? We are doing this in order to convert multiple types of data into single data. Previously you have under sex male and female is there, but now you can see for sex you only have whether it's a female or not, that value is printing, whether it's male or not, that value is printing. In embarked also, whether it's a C or Q or S, that value true or false is printing, that is a 0 or 1. Machine can able to understood this data set right now. And even I don't want this column under if you consider these 2 columns, I don't want this column. And if you consider these 3 columns, I don't want 1 column. So based on these 2 values, like if it is not C, if it is not Q, then obviously it is S, right? Yes. So I don't want the 1 column of it and 1 column of it. So in order to remove these 2, you can simply write this drop method, or else we can directly use here like if you observe drop first. So that drop first you can able to use in order to drop the first value resulted from this. That is nothing but, so for this column, for this column, this first value will be dropped, and for this second column, this first value will be dropped. Now let's run and print the data to see which data that we are getting. Yeah, now you can able to observe only male type 6 related column is there, and here embarked C is removed. Previously that the data is there, but now the data is removed, right? Yes. So now we have our data ready for training. So let's split it. Let's split the data for training and testing. So in order to observe the accuracy and multiple parameters, we need to split the available data set into training as well as testing. So how can we able to split that? So for that also we have a method in sklearn dot pre-processing. I'm importing train and test and split. So this is the method that I'm using. So actually this method is present in model underscore selection. Yes. So if you provide the wrong method, then you will get some error here. This method is present in sklearn model selection, that is a train test split data. I want to use this in order to split my input as well as output values. First, understood what is the input. In this data set, if you observe what is my input, all the other values other than this survived or not. So these all data I want to provide as input. And what output I'm expecting? I'm expecting whether that particular person with this data is survived or not. So that I want to predict. So this is my output. So in order to take input in X, I'm just using this in data. I'm just dropping what survived, and access is 1. So that I'm dropping. So what is my output? My output is nothing but data of this survived. So this is my expected output. I'm taking the data. Now this X is nothing but my input, and this Y is nothing but my output. Let's print it so that you can able to observe. I'm just printing X value right now so that we'll get the rest of the data other than survived column. You can observe here. Yes, the rest of the data I'm getting. If I print Y, then I'll get only survived column. That is nothing but whatever the expected result output. You can see only survived column I'm getting, right? Yes, this is survived column. Now I want to use this data in order to split for training as well as testing. I want training data from X, and I want test data for X, as well as for output also. For Y also I want a train data set, as well as for testing also I need one data set. So in order to split the available data set, I'm using this train test split function, and I'm providing my X and Y values. And here you need to observe the thing, that is we need to provide how, at what rate we need to split the data set. Like you can see here the test size, that is visible, right? Yes, the test size. So what does this test size indicates? This test size indicates how much testing data that you want to split. Currently you have 100% data. In that 100% data, how much amount of data that you are expecting for testing, and how much amount of data that you are expecting for training. Currently I'm expecting 20% of data for splitting test. For testing I want to use only 20% data, so that's why I'm providing 0.2. And we also need to provide the random state. You can see here, this is the random state. So what does this random state define, sir? This random state will define us by using what rate we are randomly shuffling the data, so that it specifies. You can just print the training data to understood whether it's worked or not, like we splitted this data set or not. So currently only 712 rows are there in this train data set. Whereas if you see the test data, in the test data, whatever the remaining rows are there, that will be present. You can see 179 rows. So like that, our training as well as the testing data will be splitted. Now, before passing our training or testing data to our model, either it may be only ML model or ML model with the neural networks or any NLP based model or any Gen AI model, we need to normalize our data set. So why we need to normalize our data set, sir? The first reason is in order to improve the performance, like in order to improve the running time, fastly running the algorithms. Many optimized algorithms run faster when features are standardized. This is particularly true for gradient descent based algorithms. This normalization or standardization even leads to equal weighting. This can prevent features with large range from denominations. So in this way also it will work faster. Even if we take some standard models, they think are they are actually created for already normalized data set. So if we provide unnormalized data, then we can able to observe some exceptions also. So we need to normalize the data as well. Currently we are using scalar standardization. So that is using this formula to standardize the given x values or given inputs. Here this mu indicates the mean, this sigma indicates the standard deviation. In this way we are normalizing our data or standardizing our data. Whatever the z value that we get, that is the standardized value. Now let's import standardized scalar from sklearn dot pre-processing. Standard scalar I'm importing. Now I'm creating a scalar from this standard scalar method. Then first I want to standardize this training input data. So x train is equals to, so to standardize it, I'm using this scalar dot fit transform. This actually uses mean as well as the standard deviation in order to transform our providing input train dataset. Now I want to use this trained data set in order to transform my test data as well. So that's why I'm using scalar dot transform. You might get a question that why we are using previously fitted transform method, why we are using transform method here. Since previously we are using this training data mean as well as standard deviation for creating this standardization, we provided this fitted transform method. Now we are using already previously created mean and variance data of our training data, and by using that data we are transforming or we are standardizing our test data as well. So at last let us print this train data or test data to see whether that data got normalized or standardized or not. You can see we're getting the standardized values in between -1 to 1. So you can see, so this is how the standardized data will be look like. So these are the things that we need to understood in data pre-processing stage. So first we need to load the data set, then we need to remove whatever the unnecessary columns are there. Then if there is any missing values in our data set, we must need to fill those. So by using this method in pandas, you can able to pandas data frame, you can able to fill that data, and you can able to convert the data, that is multiple data types are there. Then in order to make the data suitable for our model to understood, we are generating the dummies, and we are making the data or we are converting the data to be identifiable or to be suitable for training. That is, we are taking for each column only either true or false or 0 or 1, only numerical value we are taking. Then so in order to split our data into training as well as the testing, here you can see this is the method that we are using. At last we are even normalizing and standardizing our data to make the data suitable for our model and to make the performance faster. So this is all about data pre-processing. I hope you understood this video and you got some knowledge regarding data pre-processing of loading data set and removing unnecessary columns, filling missing data, as well as get a categorical data and split the data set, as well as normalizing or standardizing the data set, whatever you have. I hope this video is useful. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye.